So yeah, that's the last part for today. So we have to briefly now talk about the different ways in which we can apply the Phong illumination. And so the first approach is that we just say, okay, we can just compute the reflected color by using the Phong illumination model or the Phong lighting model per vertex, and then we can interpolate the resulting colors smoothly across the polygons. And that is what we call Gouraud shading. Or we can do it in a second way, and that is called the Phong shading approach. So do not, or you need to distinguish between these two different Phong approaches. The first one is the Phong lighting or the Phong illumination. That tells us how we compute the reflection at a surface point. And the other Phong, so to say, is the Phong shading, which tells us how we bring the reflection to the surface points in the interior of the triangle. Now with Gouraud shading, we have said, okay, we just evaluate the Phong illumination model at the vertices, and the resulting colors will then be smoothly interpolated across the triangle. Phong shading now says, okay, we do it in a better way, but also computationally more expensive way to obtain higher quality shading. What we do is we first let the per vertex normal vectors being interpolated to our surface point in the interior. That gives us then an interpolated normal vector. And then with this interpolated normal vector, we evaluate the Phong illumination model. It's clear that this is something different, because in the first approach, the Gouraud shading approach, we only compute or we only evaluate the Phong illumination 3 times at each of the 3 vertices of the triangle, and then we let the resulting colors being interpolated. And in Phong shading, we first let for every point in the interior, or for every point we see on that triangle, we let the normals being interpolated, and then for every point with the interpolated normal, we evaluate the Phong illumination model. So it's clear that Phong shading then is computationally far more expensive than Gouraud shading, but as we will see in a second, it also provides higher quality shading. First of all, the question, so why should we do that? Well, apart from maybe quality differences, is there some other reason why we should do Phong shading and not Gouraud shading? And there's one example which immediately tells us a little bit more about the advantage of Phong shading. Let us assume you have that triangle here. So we have normals specified at the vertices, and let us assume now you take a pocket lamp with a rather small opening angle, and you illuminate with this pocket lamp here the triangle, so that this cone of illumination falls entirely into the interior of the triangle. And now you can imagine what happens if you use Gouraud shading. Then for each of the 3 vertices, we would ask, what is the illumination? And all these 3 vertices would say, oh, I'm not in the cone, in this illumination cone of the pocket lamp, meaning I don't receive any light at all, meaning that all these vertices would simply remain black. They would not receive any color at all from the pocket lamp. And it's clear if I now do interpolation of 3 times black across the triangle points, all the points remain black. With Phong shading, the situation will be different, because with Phong shading now, let us assume I have a point here in the interior of the triangle. With Phong shading, I would now first interpolate the normal vectors to that point. That gives me then an interpolated normal vector. And now with this normal vector, I would evaluate the Phong illumination model. And here I would now determine, okay, I'm in the cone of that pocket lamp. I'm receiving light, so I evaluate the Phong illumination model, meaning that this point here would then be illuminated. So with Gouraud shading, you would not see that highlight here or the illuminated area at all. With Phong shading, yeah, you get a nice and smooth shading, including that highlight in the interior. Yeah, let us look at some images demonstrating the differences. So, and keep in mind that in all three examples here, we perform Phong illumination. The difference is, in the first example, for each of the vertices, we perform Phong illumination. But then for every triangle, or for every quadrilateral, let's say for every triangle, we just pick one particular vertex, let's say always the first of the sequence of the three vertices making up that triangle, and we take the color of that vertex and give it to all points in the interior of the triangle. That then gives us what we see here, the so-called flat shading. So there's no color variation or reflection variation across the polygons. We just pick the color of one single vertex and give this color to all the surface points in the corresponding polygon. Here now we have per vertex Phong lighting. So again, at every vertex, the Phong illumination is computed, but then we perform Gouraud shading in order to let the resulting colors being interpolated smoothly across the polygons. And then you see now, of course, we get a fairly smooth appearance, but still we have the feeling that we see the polygon structure shine through. And now on the right-hand side, what we do is for every point on the surface that is seen, and we call them the fragments. So we will come back to the fragments later on if we talk about the rendering pipeline that is implemented on graphics cards, and then we will get to see exactly what a fragment is. Let us now just assume that a fragment refers just to a point on the surface that is seen in the current image, and then for each of these points, we interpolate the normal vectors from the vertices to that point. We evaluate the Phong lighting model, and then we evaluate the Phong. We interpolate the normal, that is the Phong shading. And then we do for every point using the interpolated or the Phong shaded normal interpolation. We evaluate the Phong lighting, and this then gives this smooth appearance of the reflection pattern as seen here on the right. And you see now what it means in terms of, so to say, the smoothness, or you can think about why does the Phong illumination look so much better? Because the Phong illumination now does a linear interpolation of the normal vectors across the polygons. And if we now look at what happened at the transitions between different polygons, we could say that in Gouraud shading, we have just a continuity of the color values at the transitions between two polygons. And in Phong shading, we have even continuity in the normals, so in the orientations between the surface points at the transition between polygons. And this means, so to say, that continuity degree is of 1 higher if we use Phong shading compared to Gouraud shading, and this then gives the more smooth appearance of the resulting reflection patterns. Yeah, again here, a Phong shaded and lighted sphere. You see again we have this ambient part here, then we have, so to say, the diffuse reflection in the upper part, and then we have here the highlight, the reflection highlight, and you see we don't see any patch borders anymore. That comes just from the smooth normal interpolation which we use in Phong shading.